This lesson is on section 7.1, which is proportions in triangles. A quick review of ratios. A ratio is simply a comparison of two numbers. It can be written as a fraction, or it can be written in the words with 2 in the middle. For example, 3 to 7 would be a ratio. Or you can write it with a colon in the middle, so it would be 3.7. The units for a ratio should be the same, so feet to feet or inches to inches. That makes it different from scale factors, which is also what we're going to talk about. Those can have different labels. Okay. Proportions, we're going to be using proportions in today's lesson, so a quick reminder of how to solve those. A proportion is simply two ratios or two fractions set equal to each other, and you solve them by cross multiplying. So in this case, you would cross multiply the 4 and the 8, and that would give you 32. And you would cross multiply the x and the x, and that would give you an x squared, and the equal sign stays in the middle of them. So to solve this one, you would take the square root of both sides, and x would equal the square root of 32. Same thing over here. It's a proportion, so we cross multiply. The equal sign stays in the middle. 10 times 20 is 200. That's what goes on one side. The other side, when you take 4 times x plus 2, you have to use the distributive property because it's 4 times more than one thing. So that would be 4x plus 4 times 2 is 8. So it would be 4x plus 8. And then we would use our algebra to solve. So we'd minus the 8, and we'd get 4x equals 192. And then we'd take 192 divided by 4, and that would give us 48. When we talk about scale factors and scale drawings, our scale factor is a ratio. It's either a ratio that takes a smaller figure to a bigger figure or from a bigger figure to a smaller figure. The difference between a scale factor and a ratio is that the units can be different. A scale factor can read something like 1 inch is equivalent to 16 feet. Notice the units are different there. That makes it different than just a plain ratio. An example of a problem in which you might need a ratio. It says the scale model of a boat is 9 inches. The boat's actual length is 60 feet. Find the ratio of the length of the model to the length of the boat. Okay, the first thing you have to pay attention to is when it says find the ratio, make sure that you're going to do it the right way. Okay, whether we go 9 to 60 or 60 to 9 depends on what the question is asking. This one specifically asks us to find the length of the scale model to the length of the boat. So we're going to put the scale model number first, the boat value second. Now it says 9 inches to 60 feet. It's asking us, however, to find the ratio. So a ratio has to have the same units. So to change this, we would take 60 times 12, and it would be 9 inches would be the same as 720 inches. 60 times 12, because feet to inches. And then we would reduce it down. If these are reducible, we would do that. We would simplify. 9 goes into 720 80 times, so the ratio would be 1 inch is equivalent to 80 inches. 1 inch in the scale model is equivalent to 80 inches in the actual boat. Maps use scales all the time. One particular one uses 1 centimeter equals 20 miles. If the county is 90 miles wide, in real life, how wide is it on the map? There are a couple of different ways to solve this. The easiest way to do that is using a proportion. So we are going to set up something over something equals something over something else, and we're going to solve it by cross multiplying like we did up above. How you set this up, there's a couple of different ways. Okay. Usually you use the scale and you set that up as one fraction, so 1 centimeter equals 20 miles. And then on the other side, you have to be sure that if it's centimeters over miles on one side, it's centimeters over miles on the other. So our other value is 90 miles, so that means the 90 would go on the bottom and the x would be what goes on top. You can, however, do this a different way. I've had some people say, well, 1 centimeter over, well, centimeters is what I'm looking for. So I can compare that to 20 miles over 90 miles. Either way would be an appropriate way to set up the problem. Notice that when I cross multiply using either setup, I'm going to cross multiply the x and the 20 on one side and the 1 and the 90 on the other. X and 20 on one side, 1 and 90 on the other. It doesn't matter which way you set it up, you will get the same answer. So we would, either way, we're going to get 20x equals 90. So I divide by 20, and I get 4.5. So this county would be 4.5 centimeters on my map. That is the end of the lesson. Here is your homework according to the class that you are in.